All right, so we're looking at, whoa, that's a little fast. When we look at 3D shapes, we have these things that we call nets. And a net, you can almost think of it like a pizza box, right? You guys ever seen a flat pizza box? Yeah. This is a flat piece of cardboard. You start folding up into creases. All you have is 3D image. And it's very similar to basically what a geometric net is. We're just taking that shape and creating a 3D image. And I know this definitely predates your time, where I couldn't believe the day when I actually opened up one of those sugar bomb cereals and in there sat a digital video game on a CD. Like, remember in the good old days, you had to cut out the stupid dice from the back of the box and it actually became your game board. Yeah, you guys are looking at me with weird looks, yeah, it tells me exactly where I'm at. All right, so of course you guys don't remember that.
I remember that.
You guys probably don't even remember alphabets.
Alphabets.
Alphabet cereals?
Oh, yeah. I
Was it like the
never
cereal?
ate it. I get it now, alphabets.
Were they like little alphabet?
Yeah.
The spaghetti?
I know you guys.
Were they like Cheerios? Kind
Yeah.
of?
Were they spaghetti?
Yeah, they were just shaped like
They sound familiar.
I remember.
Anyways, so a net. All a net is a 2D representation of a three-dimensional figure.
So it's not 2D.
And all of it, if you really want to think about it, is the unfolded three-dimensional figure. A lot of times we refer to these 3D figures as polyhedron, and that's singular. Poly meaning many, hedron meaning faces. So that's a singular object, a polyhedron. So polyhedra is plural. So that just means we have lots of 3D figures. When we talk about polyhedra, there are three things I want you guys to be aware of. There's a thing called a face, an edge, and a vertex. The flat panels, the planes, can you remember the one that in the first term? Okay, the planes are your faces. Where your faces intersect, what type of geometric figure is created? Look at the figure. When I have two faces that intersect, what type of shape is created? A line. Okay, so your edges are the lines, or the intersection of the faces.
I like these notes.
And when I have two or more lines that intersect, what do I create? What type of geometric figure? Okay, so you guys take two lines, intersect them, what does it create? A point. Yep, a point of concurrency creates a point. So your vertices are just the points. So we have our edge right here, the base is the plane, and then where they all intersect, that's called the vertex. Remember, that's the intersection of the edges. So some of you guys might really struggle with this because you're going to have to challenge your visual spatial skills here. I want you to look at this image. So here's our net. It's been unfolded. But if I put it back together, what type of shape do I create?
A 3D.
Called on a rectangular prism, right? Yep. So that's what I want. There we go. So rectangular prism. Alright, so looking at this again. This rectangular prism is made up of different shapes. What are the types of shapes that are created here?
Square and rectangle.
Okay, so there's squares, and there's rectangles. How many squares do I have?
2.
2. How many rectangles?
4.
By the way, how many sides does a square have?
6.
Square. 4. How many rectangles do we end up getting? 4 rectangles. What if my 2 bottoms down here were triangles? How many rectangles would I have? 3. What if those were pentagons? 5, okay? So these shapes right here, we call those the bases of the prism. That's the base of the prism. So it's not the rectangles, it's the end caps. Okay, if you want to think like that. It's the 2 ends of the prism. Alright, now it's going to get really tough. See if you guys can do this. Try putting this back together. Label the vertices. So you see how all these are labeled A, B, C, D, E, F, G, H? So then I want you to label your vertices. So I want you to label this point, this point.
On either side.
Yep, all the way down. I want you to label all those vertices. Now where should we do this down? Okay. So guys, what's the name of this point right here?
I.
A.
The A is correct. Okay, what about over here?
B. A.
We're gonna do that.
Think about G is going to come back up as this is folding up. Means that G. Okay, what about this one?
D.
Say that again?
D.
B. And this one?
F.
This one.
C.
How do you find surface area? What is surface area? Put in your own words, simplest definition. Victoria?
The area of all the way around.
What do you mean all the way around?
Like on every face.
On every face, so area of all the faces, right?
Yeah.
Alright, so this isn't so bad. Now knowing what all my vertices are, I can find my surface area fairly easily. All I gotta do is find the area of each section. And since these are all rectangles, that's 6, so therefore I know this is, and this must be 6. But what about the lengths right here, the width?
4.
They're all 4s. Okay, so here we go. Area of this section, 16. Area of this section, 16. Okay, and then the area of these, 24, 24, 24, and... Okay. So let's put this all together. What do I actually have then? I have 2 16ths, right? And I have 4 24s. Because I have 4 rectangles. So what's 2 times 16?
32.
Plus,
96.
gives me 28 what?
Inches squared.
Alright, so how bad was that to find surface area?
Not bad.
Is that something you guys want to do every time? Constantly had to find the area of each individual section? Or does it seem like there might be an easier way?
Might be new.
Might be an easier way. So let's go ahead and skip a slide.